Good evening students, welcome back to the class, and in today's class we are going to discuss about the electrochemical series. For that we have to go back to the reaction of the Daniell cell, the overall reaction of the Daniell cell. So I think so you can recall the Daniell cell reaction. It was Zn plus Cu2 positive, Zn 2 positive plus Cu. As you can see, the copper 2 positive is getting reduced to Cu and Zn is getting oxidized to Zn2 positive. If we consider the zinc only, then the zinc metal is converted to the ion form. So what is the agent or who is converting it, helping it to convert the zinc to Zn2 positive? Obviously the Cu2 positive, right? So this Cu2 positive is acting as an oxidizing agent, the agent that helps the other metal in getting oxidized. So that is the oxidizing agent. So this is your oxidizing agent. Now how does it help? Initially Zn, okay, it was having equal number of electrons and protons. Now you see here this copper 2 positive, isn't it? 2 positive. From the zinc, it has to take up the 2 electrons, then only zinc will be converted to ion form. So it has taken up the electrons. How many electrons? 2 electrons. So electrons, you know, it's negative, so charge is negative. So 2 positive charge and 2 negative charge, it makes what? 0. So copper 2 positive is having now neutral charge, that is 0, and then from Zn 2 electrons were removed, so it became Zn2 positive. Is it clear? Now if you consider the other side, from other side means from the copper side, then you can observe that this copper is getting reduced. Who is reducing it? The zinc. So Zn is acting as a reducing agent. Okay, that is why it is said that a reducing agent itself gets oxidized. It has to get oxidized, then only it can reduce the other metal. Similarly, copper is an oxidizing agent itself, it has to get reduced. It will take up electrons, then only it can oxidize the other element. So you have got in the schools in your book that oxidizing agents get reduced and reducing agents get oxidized. So this was actually the method of redox reaction, because in redox reaction oxidation and reduction takes place together simultaneously. If oxidation is occurring, then reduction has to be occurring. Clear? So now let us move on to the electrochemical series. Electrochemical series. This series is actually an arrangement of elements in order of increasing electrode potential. The increasing of electrode potential. Okay. Now if we consider some elements such as Cu, okay, if we consider Cu, you can write the ion form here. Okay, I will not write now. See, you can consider then nickel 2 positive, then nickel, after that Zn 2 positive, Zn. Is it clear now? So this copper, nickel, zinc, and in between here, between copper and nickel, you will get hydrogen. Okay, hydrogen means this. Okay, and you know that the electrode potential for hydrogen was 0, but this will have some value, this will have. Can you tell me whether nickel and Zn2 positive will have negative or positive values? It will have negative or positive values. This will have negative value, no? You already know what this was, minus 0.76, isn't it? And for copper you can say it was positive 0.34. So electrode potential for Cu2 positive, Cu is plus 0.34, because this is what electrode potential means, reduction potential. The tendency to get reduced for copper is more than that of zinc. Therefore, in a reaction where zinc and copper electrodes will be there, copper will always get reduced, zinc will always get oxidized. The opposite thing will never happen. Okay, and this is determined where the elements lie in the electrochemical series. So let us go to the application of electrochemical series, in which we'll understand more details of this arrangement, as well as how they react when placed together, as well as what is their electrode potential, okay, and whether they are oxidizing agent or reducing agent. So all these things we'll study in the relative strengths of oxidizing and reducing agents. We will try to relate, we will try to compare the oxidizing and reducing agents, and this is one of the application of the electrochemical series. So now listen very carefully. In the electrochemical series, the substances are arranged in decreasing order of electrode potential. Decreasing order of electrode potential means highest here, lowest here. Clear? In decreasing order of electrode potential, which is equivalent to reduction potential. We have discussed this thing, and today I have little bit said about it. Okay, so I think so this is clear how electrode potential and reduction potential is similar. So in the electrochemical series, at the topmost metal is having the highest electrode potential. Now you see, highest electrode potential means that element placed at the top will have the highest reduction potential. Is it clear? It will have more tendency to get reduced. And the element that is placed at the lowest, at the bottom, that element will have the lowest electrode potential. It will have less tendency to get reduced. It will have more tendency to get oxidized. Clear? So let me repeat once again. In the electrochemical series, the substances are arranged in the decreasing order of electrode potential, that is decreasing tendency for reduction. Yeah, decreasing. If you compare the copper and zinc, no, so this copper was having higher electrode potential, positive electrode potential, and this was having the negative electrode potential. Is it clear? And this has less tendency for getting reduction. It is getting oxidized. Zn is getting converted to Zn to positive, right? And this will act as more powerful oxidizing agent, because this is getting reduced. Now copper is getting reduced, so since copper is getting reduced, it will act as oxidizing agent. So the elements which are placed at the top are good oxidizing agents, while the elements placed at the bottom side is having the less oxidizing agent. They will act as reducing agents. Is it clear now? So let us write now here properly. So here oxidizing agent is there, okay, at the top. Here reducing agents are there. Now this is having more tendency to get reduced, okay, and this element will have more tendency to get oxidized. This is having the highest electrode potential, lowest electrode potential. Is it clear? Every term I have explained how it is related to each other, because oxidizing agents getting reduced, okay, and whenever an element is getting reduced, that is related to electrode potential. Reduction potential is equivalent to electrode potential. So the elements at the top are having the highest electrode potential, while the elements at the bottom will have the lowest electrode potential. Is it clear? Now The substances which have lower electrode potentials are strong reducing agents, while those which have higher electrode potential are stronger oxidizing agents. So this side it was what? Positive, right? Positive, and here it is negative. In between there will be one element where you'll get 0, because you know in a graph between positive and negative what is there? 0 is there. No, in the scale also, if you see, to your left hand side negative and to the right hand side positive, right? So in between 0 is there. So this 0 potential is having SHE, you can see, no, standard hydrogen electrode, okay, where hydrogen electrode will have the 0 potential.